Alright, let's talk about electrons. Some of you might ask, why electrons? Put simply, electrons and their interactions with protons and other subatomic species, including other electrons, form the basis of all chemical reactions. And as you all know, reactions are a fundamental part of chemistry. For chemical engineers, having a clear understanding of electrons comes in handy when we're trying to make sense of why reactions take place and why atoms and compounds of different elements behave the way they do in various processes. So first, let's get something clear. Electrons can behave as waves or particles. That's why you might see pictures of atoms looking like this instead of this. For the purpose of keeping things simple, I'm going to treat electrons as particles in this video. So most of you already know electrons are negatively charged particles orbiting a nucleus containing protons and neutrons in what is known as a shell. What you might not know is that within these shells are subshells and orbitals. I like to think of the atom as being a hotel, and the shells would be the floors in the hotel. These subshells are the different types of rooms, like maybe a double room or a family room, whereas the orbitals would be the bedrooms inside each type of room. In this hotel, price equals energy, so higher floors or larger and expensive rooms would have higher energy and thus lower stability. So if I'm an electron with some friends and we are looking for a suitable hotel, we will have to get assigned to a floor or shell, choose our type of room or subshell, and choose our bedrooms or orbitals in each room. By the way, each bedroom can only hold between 0 to 2 electrons, so all good, right? Well, not yet. There are some rules at every hotel. First up is Hund's rule, stating that every orbital in a subshell must be singly occupied with one electron before any one orbital is doubly occupied. Then there's Aufbau's principle, stating that orbitals' energy levels are filled in order of decreasing stability, or in other words, the cheaper rooms on the lower floors have to be filled first. Finally, there's Pauli's exclusion principle, which states that no two electrons can have the identical quantum mechanical state in the same atom, implying that two electrons sharing the bedroom need to spin. Yes, electrons have spin in opposite directions. Life as an electron is tough. No wonder they are always so negative.